Okay, so we're going to go over how to find domain of a function from its equation. That is definitely one of the harder ways to find domain. There are 5 ways that we really represent functions. The 5 ways are really represented in the packet throughout, maybe more you can kind of see on this page. So one way is by a graph. Now a graph could be something that looks like this or like this, okay? These are all graphs. That's 1. 2, a table of values. 3, a mapping diagram. 4, a set of ordered pairs. And 5, the more challenging way for most people is by an equation, okay? This equation is just another representation of data, of information, just like a graph is, just like a table of values. All these things are just ways of representing data or information, okay? Now, when you're younger, you might first learn like this type of a pattern of some sort, right? So you might learn, I'm just gonna kind of dive into an example here. Say that the pattern you get is like, okay, our first term in the pattern is 2. The second term in the pattern is 7. The third term in the pattern is 12. The fourth term in the pattern is 17. Dot, 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 right? So when you were younger, you might learn it this way. This is sort of like a table of values. The term number is sort of like your input, and then the number of the pattern placement that it is sort of like your output. So you do have a domain, you have a range. Your domain might be like 1, 2, 3, 4, dot, 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 and your range is going to be 2, 7, 12, 17, and maybe when you were younger, you figured out a pattern for this. What pattern do you see in this case? How much is it going up by? If you were a kid, if you were like, oh, the next number will be blank, even without a formula, could you figure out what's next? Look at the numbers, 2, 7, 12, 17. Okay, it's going up by 5, increase by 5, increase by 5, increase by 5. So if I asked you, if this is X and this is Y, write an equation that represents this information. The information is really limited to only these values. If I graphed it, it would really be just those points. So I'm just going to go over here. I'm going to sketch a little bit of a graph. All right, so the biggest number looks like 17. So that's 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. I don't know if it's all showing. No, it just fits. And 1, 2, 3, and 4. So if you were plotting these points, you might say over 1, up 2, over 2, and up 7. But people would say, oh, it's going up by 5, x plus 5. Is that correct, though? If I plug in 1 for x, do I get the right answer? No. So when you're going up by 5, that doesn't really mean you just put a plus 5 in the equation. If I keep plotting these points, over 2 and up 7, so it's 6, 7 right there. Over 3 and up 12, so it's 7, 8, 9, 10, 11, 12. Over 4 and up, 1, 2, 3, 4, 5. You just told me it's going up by 5, right? Do you see where it's going up by 5? It goes up by 5 to get to the next term. Up by 5 to get to the next term. Up by 5 to get to the next term. Could we write an equation to model this data if I wanted an equation that passes through it? What kind of equation should this be? Is it quadratic? What is it? It's linear. So linear equation for sure. And when you write a linear equation, maybe you think of this, y equals mx plus b. Maybe you think of y minus y1 equals m times x minus x1. Maybe you think of ax plus by equals c. All of these are just different ways to write a linear equation. If I continued the pattern backwards, it's sort of a cheap way to do it. I'm going to go down 5 over 1. What did I find out to kind of help out my equation? If I went down 5 over 1, how did I kind of help myself a little bit? I found the, what was it? What is this? Yeah, we found the y-intercept. What else do I know? I'm going up 5 over 1, up 5 over 1. Yeah, so I can really use this one right here, right? What would the equation end up being? Y equals? 5. Y equals 5. X minus 3. So now we have an equation. When you had a table of values, if I asked you for the domain, you would just list off the numbers in the table. But when you have an equation, the equation really represents every single speck between all of those dots. This is still a dot, a dot, a dot, a dot. These are all points. So the equation is all encompassing. It has so much more to it. When you get a graph of a linear equation, whenever you get a graph of a linear equation, if you think about what a linear equation in general looks like, doesn't a linear equation always look something like this? Right? What's the domain going to be? Right. All of our linear equations, unless it's a vertical line, all of our linear equations, whether it has a positive slope or a negative slope or even if it's a horizontal line, they all have a slope of negative infinity to infinity. Lines, no problem, right? No funny business, no weirdness. Any x value is fine. You can plug any x value in, multiply by 5, add 3, subtract 3, multiply by 2, whatever. Multiplying, dividing by numbers, adding or subtracting, nothing's weird in a linear equation. So all of our linear equations, okay, when they're in equation form or graph form, the domain is always going to be all real numbers. Same with the next level up. Like this is a linear binomial. What's 1 degree higher than a linear? Starts with a Q. Yeah, what was it? Quadratic. So if I have a quadratic, y equals x squared plus 7x plus 6, or y equals 3x squared by itself. Y equals negative 2/3 x squared minus 8. It doesn't matter. They're all quadratics, okay? Every single one of these is a quadratic because this decides its look. What does x squared look like? We derived the parent function that day when we plugged in all the different values. Right, so if it's just plain y equals x squared, we derived that graph, we talked about its pattern, we talked about its shape. Sorry, this line's crooked and we'll stop here. Here, we went over 1 up 1, we went over 1 up 3, we talked about the odd numbers being between all the perfect squares, over 1 up 5, over 1 up 5, okay? So here I have a parabola. These are just other parabolas. How are they different? Maybe it's skinnier, like a slope is steeper. If it's negative, maybe it's just opening the other way. This one might just be more narrow. The vertex might be moved somewhere. Parabolas get wide forever and ever in both directions, right? It keeps getting wider. Out 1 up 7, out 1 up 9, out 1 up 11, out 1 up so on and so forth. So if your parabolas keep getting wide forever, what's the domain of every parabola? Every time, okay? The domain is still going to be negative infinity to infinity for the domain. All good, okay? Now, what we'll learn later, but we'll just point it out a little bit right now, as your degree gets higher, if you have in another equation, then you could have other numbers, blah, 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 but if your biggest guy is x cubed, right, even if you add or subtract other things to it, the shape kind of looks like this. Guess what the domain is? Yeah, negative infinity to infinity. It's wide forever. Nothing goes awry, nothing goes wrong when we're just dealing with a polynomial. They're safe. Polynomials, no weird things happen. As I have x to the 4th, you're going to see that we can get more curving to it. That's all that happens. They just get bouncier. It's not that serious. You see like these arrows, we've been seeing them in graphs and getting more like accustomed to them. They're really telling you that the graph gets wide forever in both directions, right? It just keeps going out. If you have x to the 5th, if it's quintic. I know I typed 5th degree somewhere. I wrote 5th degree on the answer key. I don't know why I did that. It was on the first page when I was expanding the factored forms. I don't know. I was distracted, sorry. But 5th degree, but it's really, you should say quintic. So they just get more curvy, but it's still going to have a domain of all real numbers. But now, which examples don't have a domain of all real numbers? What kind of equations mess us up?
Factors.
Well, not just factors. What do you mean? What kind of equations? What rules? What math rules do we have? Some math rules we have. You are not allowed to, these are old rules, to divide by what number? 0. We are not allowed to divide by 0. Now, when you are building an equation, divide by 0. Well, where does division come in for equations? Where would you see division happen? I usually don't write this symbol, but we write this thing. What's this thing? Fraction bar, right? So anything above the fraction bar is your what? Anything above the fraction bar is the numerator, and anything below the fraction bar is the denominator. Which thing are we dividing by? Are you dividing by denominator? Okay. Anything we're dividing by, where is that? In the numerator or in the denominator? Right. So we're not allowed to divide by 0. Here's what a fraction looks like in an equation. If we're not allowed to divide by 0, what's the next level of the rule? If we up the rule a little bit, the denominator, which is what we're dividing by, right. So your denominator, is not allowed to equal. That's literally what you could write. Can't equal. Not allowed to equal what number? 0. Now make up anything you want for your denominator. If you want your denominator to be, so if I make up an equation, f of x equals 2x plus 11 over x plus 15. What's the denominator in this problem? Right. And the denominator is not allowed to equal 0. So you just straight up, you're literal, okay? Your denominator, write that down algebraically, x plus 15 is not allowed to equal 0. I write cannot equal 0. That's it. And then all we do at this point is solve as if you were solving for x, but really what you're solving for is what x can't be. So how do I get x alone? We subtract 15 from both sides. We're getting x alone because we're finding out what x cannot be. So then we're left with x cannot be negative 15, right? So we took our denominator, we said it cannot equal 0. Now sometimes more than one thing make it equal 0. In this case, it's just that right there. Now, I asked for answers, say, in interval notation. I'm telling you x cannot equal negative 15. Domain tells you what x can equal. If x cannot equal negative 15, what can x equal? So really, it could be literally anything else. Anything on this side is good, right? Anything over here is good. The only thing off limits is 15, negative 15. But can I get close to it without you knowing, like, that I'm not coloring negative 15? Am I supposed to just keep going closer and closer and closer? No. How do we mark it up? Because like then I'm going to be like, okay, I colored everything except negative 15. Can you tell? No. How do we mark it up so that you guys know for sure? So what do we do? Big fat open circle. This way nobody's confused. We put a big fat open circle on it. And that's just so we know it's not there. Okay? Now that's just the number line to help us get a visual. So what is the interval notation for this domain now? Interval notation for the domain. So we just heard from Sarah, it was this, negative infinity to negative 15, not including negative 15. I'm running out of room here. I'm just going to do one of these and take it. Union, uniting it to the next piece, right? And then we start up again at right after negative 15, comma, infinity. Okay? And that's it. That's all we got to do. Scoot this here so the whole thing's on the screen. Okay? So your domain, think about what domain is. Don't just memorize. Domain is x. Domain is the x values we are allowed to use in our equation. They work for it in our equation or on our graph, wherever. So with an equation, yeah, it's a little harder to see, but it's really, there's two main rules you're gonna have to deal with that make things difficult. Basically, the denominator situation, oh, sorry, I cut that off. The denominator situation and one other situation. What other situation messes us up with domain? Can cause issues for our x values, allergic reactions for our problems. Like this problem, like maybe it's allergic to peanuts, can't have peanuts. Don't give it peanuts, not defined when you give it peanuts. What's a peanut? Negative 15. The problem won't work because you'll get a 0 on bottom. But what other types of problems? Not only ones with denominators, but what else?
Square root.
Okay, radicals. So radicals can cause us some issues too. What is the rule? So one of our math rules, we're not allowed to divide by 0. What's another math rule that I could add to my list? Math. Well, slow down, go back. Basic, don't go right to the technical part. Math rules. You are not allowed to take the square root of what kind of numbers? Right, of negative numbers. So these are the two main obstacles we run into. You're not allowed to take the square root of negative numbers, and we're not allowed to divide by 0. Okay, so what's the square root look like? If I were trying to write an equation with the square root in it, I have f of x equals the square root of something. Well, now I got to put something in my square root. Make up something, whatever you want. 6x minus 31. Ooh, sorry, cut that off. Okay? I'm not allowed to take the square root of a negative number. How am I supposed to know what number makes this negative? Guess and check. Just pick out of the sky. If you can't be negative, what can you be? If you can't be negative, you can be blank or blank. What can we be? You cannot be negative, you can be positive. Or, what else is not negative but not positive? There's a special number that can't be positive and it can't be negative. 0. 0 is not positive or negative. So if you can't be negative, you can be positive or 0. Now, what's the name of the thing under the radical? Do you remember what this is called? Starts with an R. It's called a radicand. The radicand can be positive or 0. How do you say something's positive? All positive numbers are? Where do you find positive numbers on the number line? Right, all the positive numbers are greater than 0, and all the negative numbers are less than 0, right? You with me? Okay, so positives and negatives. The radicand can be positive, so it can be greater than, come on, look alive, can be,
Greater than or equal to 0.
right, because it can be greater than 0, which is positive, or equal to 0, which is 0. So your radicand, you just take whatever's in the radical and you say it can be greater than or equal to 0. So in this problem, 6x minus 31 can be greater than or equal to 0. So you take your radicand, which is the thing under your radical, and you say it can be greater than or equal to 0. Now, I got to find domain, which means I got to solve for x. So how do I find x from here? How do I solve for x now to help me with my domain?
You subtract, no, add 31.
So 6x is greater than or equal to 31, and then divide by,
6. You just leave it.
and we leave it alone. We do not try to go crazy, but we will have to, you're not going to make a decimal, you're not going to make it a mixed number. Now, on my number line, here is 31 over 6, greater than or equal to 31 over 6, so it's colored in at the point, and then we shade to the right, but the final answer is supposed to be an interval notation. So, where do we start, and where do we finish? This is colored in,
No.
starts here,
31 over 6.
then,
2 positive.
okay, but I need my,
It's bracket and then parentheses.
yes, and then that's it, you're done. That is all you really need to know. So when it comes down to it, most of the examples, the domain is all real numbers. The only two cases where it's not all real numbers, you're going to look for which two big features. Either it's going to have a, what? What will it have if it's not going to be all real numbers? It's either going to have a, not a 0, like when you look at the problem. A square root symbol for now, okay? Obviously, like, things get more intense in the future, but like right now on what we're doing, okay? Or it's going to have a fraction bar, like not just any fraction, a fraction where x is involved, like in the denominator, okay? Not just like a fraction, like 2/3 is not dangerous. 2 over x is dangerous. Like if x is on the bottom, that's where you have a problem. Like if I had a fraction and it looked like, let's even say f of x equals 5 over x squared plus 3. I have a denominator, right? You would think it's dangerous. But I need to find out what would make my denominator equal 0. Can x squared plus 3 ever equal 0? It's not allowed to. When you square something and add 3 to it, could it ever equal 0? Why not? Because I asked. What if we tried to solve this? What would you do to both sides? Okay, so now we have x squared is equal to, or is not allowed to equal negative 3. Will that ever even happen? Can you square something and get a negative number? No, so this never happens. If this never happens, then my domain never gets messed up. This will never be able to equal 0. It's impossible. It never happens. So what's your domain if you have no issues? Every number's allowed. There's no number that's bad. There's no allergy. We're not allergic to anything. No, I'll never find anything that I'm allergic to in this problem. So your domain would be what if you don't have any issues? Yeah, all real numbers, or negative infinity to infinity. That's it. Similarly, if we had something like f of x equals whatever on top, doesn't matter. What if I had x squared minus 36 on bottom? What number or numbers are bad for this expression? Which ones would make the denominator equal 0? How would I set it up? I have my denominator. How do I set this up?
But one just did, we don't have to write the negative infinity to negative 3 and then u negative 3.
No, because we never even got to solve for x. We started to, but we got x squared is not allowed to equal negative 3, but x squared will never equal negative 3. It's impossible. When you square something, you always get what kind of answer? When you square something, will you ever get a negative answer? No. If I tried to keep solving this, I would have to take the square root of both sides. What did we just say the second rule is? You're not allowed take the square root of a negative. So like, that's bad, it doesn't happen. All right, but here, we could solve this one two ways. We could start doing the same thing. What can I do to solve this one?
X squared minus 36 never equals 0.
Okay, now keep going with this one.
Add 36.
Sure, we have x squared is not allowed to equal.
36.
Then
X squared root
x is not allowed to equal.
6.
Hmm? What do you do when you take a square root?
You have to,
What do you have to include when you're the one taking the square root? Yeah,
negative or positive 6?
yes. So plus and minus 6. Because what happens if I plug in negative 6? What's negative 6 squared?
30.
What's 36 minus 36? Oh no, bad. Not allowed to divide by 0. So it can't be in the domain. We can't have 6 or negative 6 in the domain. Because if I try to put them in, it won't work. So it's like you have a machine and you can't put certain parts in it because if you put those parts, these like things in the machine, it breaks. Okay, so it's like, oh, whatever you do, you know, in my car CD player, do not play any Blake Shelton CDs because my car CD player will break. I don't know why, it just breaks when you put a Blake Shelton CD in it. Okay, and then you go, if you try to plug it in, the CD player is going to break. So like the domain is telling you, you can literally put any other singer in the CD player. You can put like a computer CD in it, it'll be fine. But if you put Blake Shelton in my car CD player, it's going to break. So it's like here, if you put in 6 or negative 6, it doesn't work. We're going to get 0 on bottom, can't do that. Then we're left with 5 over 0. And what's 5 over 0? It's not defined. You're not allowed to have that. Another way to do it, think about it. What if I factored the bottom? Can you factor x squared minus 36? Can we factor x squared minus 36? How does that factor?
X plus 6, X minus 6.
Now, you could do what we did up there and just set each parenthesis, x plus 6 can't equal 0, and x minus 6 cannot equal 0. These are just little bonuses. It's not really, because then you won't forget the plus minus. And you've been factoring a lot, so like it shouldn't be a big deal. So it's like x can't equal negative 6, and x can't equal 6. And it's the same thing. So if I had a number line, which two numbers are excluded from my domain? Just negative 6 and 6. What's allowed in my domain? Everything else. So everything between, everything on this end, everything on that end. They're all allowed. How do I write that answer with interval notation?
Negative infinity to negative 6.
Negative infinity to negative 6.
Again, negative 6 to positive 2 to 6. Oh.
So we have two union symbols because I have two breaks. I can't have that number or that number. These are a little like more intense. Not that it's that wild, but it's just like a little step up from like a plain symbol bottom like, where was it? That other example from before, right? We just had that on bottom, but just to show you for what the future holds. Okay, so that was just a little bit more to do with domain and a couple of options on how to deal with it. But when you write domain, we've been writing our domain using interval notation, so make sure you take your time and write interval notation. I'm not asking for inequalities, okay?